Hi everybody, welcome back to the DS3 podcast. I'm here today with Professor Lucy Lai from the Cognitive Science Department. She's a new assistant teaching professor here, and I'm really excited to welcome her to the DS3 podcast to share a little bit about her experience and about computational neuroscience and how data science is applied in that every day. For our listeners who don't know you yet, would you like to tell us a little bit about yourself and your journey to where you are now?
Yeah, so hi everyone. My name is Lucy Lai. I am a new assistant teaching professor in the Department of Cognitive Science here at UCSD. My path, was pretty linear in the sense that I always knew I wanted to become a professor one day. It was kind of unique in knowing that pretty early on because I always knew that I loved to teach. So in college, I went to college at Rice University, which is in Houston, Texas. And from there, I got interested in research pretty early on, and I was lucky enough to have a professor that really cared about my sort of development as a scientist. So he really mentored me through my undergraduate years, and then after that I went straight into my PhD, which I did at Harvard. And that's when I got interested in studying decision making, particularly computational models of human decision making. And then after that, I took a little bit of a side quest and lived in Japan for 2 years, traveling around Asia and also being affiliated with a university there on the lovely island of Okinawa. So after all of that, I finally ended up here in San Diego, which is also a very, very lovely place to live. And I got here about 8 months ago. So started my first year here as a professor in the fall, September 2025. So yeah.
Oh, that's so awesome. And I didn't know you were in Okinawa for 2 years. That's so cool.
Yeah.
How would you say the settling here at UCSD has been for you so far?
Yeah, I mean, it's been a whirlwind. They say that the first year of being faculty is definitely one of the most challenging because you're kind of getting used to your new role. You're no longer like a student or a trainee, so you're like the one in charge of everything. And on top of that, just like prepping all the new courses to teach. But it's been really fun.
Oh yeah, and for the audience, what courses do you teach here? And I'll ask a little bit about any prospective courses that you hope to teach soon, but what are you teaching right now?
Yeah, so I primarily teach the upper division cognitive science machine learning courses. So cognitive science as a major has many different specializations. One of them is machine learning. So I teach a lot of computational courses such as Cogs 109, which is kind of like an intro to machine learning course. I'm developing Cogs 118D, which will be about modeling behavior, human behavior. And I also teach an intro class, Cogs 9, which is Intro to Data Science. And that one is pretty general, pretty broad for anyone who's interested in data science. And a bunch of other courses I'll be teaching in the future. So stay tuned.
That's so awesome. I guess I wanted to bounce around a bit, but I think I read up that you had 2 new courses in development. So one was kind of on living and learning with AI, and the other one is about how people form beliefs. And kind of how would you pitch these classes to a cognitive science student who wants to take them for the major, or a data science student who wants to take it as an elective?
Yeah, great question. So one thing I love is developing new courses, new curriculum for students, especially in our changing world, and the kind of knowledge you guys need to know as students is really rapidly evolving. So one of the courses I've been wanting to teach, for a while is just thinking about how we should adapt to this new world where AI is very prevalent in every aspect of our lives, and for students also very prevalent aspect in their learning, right? So right now, a lot of students are basically exporting their brains to, Claude or ChatGPT because, I understand they're under a lot of stress, and it takes a lot of mental effort to think through, difficult problems themselves, right? And they have so many classes. But this course is really a deep dive and really like critical thinking and even debate into how we should be thinking about AI, how we should be thinking about using it on a personal level, like for our own learning, but also like the impacts of AI on society, on the future of the workforce. How is it changing the way we work, right? How can we use it without essentially rotting our brains away? And other topics such as environmental impacts of AI as well. So I feel like this is really critical for us to discuss, you know, because this is like what the generation is graduating into. The other course, which is about the cognitive science of beliefs, is more like personal to me and my own interests, which is a course that kind of explores like how human beings form beliefs about things, about the world, about religion, how different aspects of society and just of the limitations of our brain influence the things that we tend to believe or tend not to believe. So yeah, this is just a area of high personal interest to me, because I think that what we believe, you know, determines what we do and how we act in the world, and you know, sometimes can create like conflict between people. So I feel like that's really important to understand.
Yeah, that's honestly so cool, and I think especially for data science students, where, you know, I think the tech field is definitely one in which everyone's freaking out about AI and, you know, it kind of replacing our jobs and all of that. So I think it's really important to learn how to use AI in a way where it's like, instead of replacing your instead of replacing your thinking, it's just supplementing it. And I think that's really awesome. And then, you know, in terms of modeling beliefs and things of that sort, I kind of wanted to, you know, jump back into your field of research. I know you've studied kind of computational models of decision making, and I wanted to ask you, you know, how would you describe your research and your thesis to, you know, a layperson, and then following that, how would you explain it to maybe like a data science student here at UCSD who has a little bit more of a computational understanding?
Sure, yeah. I mean, a one-liner of my research and my dissertation is, you know, I studied how people learn and make decisions under limited cognitive resources. So, for example, how do we make decisions when we're under limited time pressure, or when we don't have enough information, or we can't remember everything that we need to in order to make the best decision, right? And so one result from that is that, you know, under limited computational resources, so that's one way to formalize cognitive resources, to think about your brain as a computer where it has limited memory storage, for example, or limited processing power, where you can't always be, you know, integrating all the relevant information to make the best decision ever, right? And so it turns out that under limited resources, we tend to fall back and rely on what we call like default behaviors, or we fall back to choices that we've made before. So a really concrete example is like, let's say you're going to the grocery store to buy some groceries, and you're in a rush and you didn't prepare like a grocery list or anything. And so in that circumstance, the most likely thing you would do is just go like buy the very most common items that you usually tend to buy for your groceries, right? And you're not trying to venture out and explore more options at that point, right? In terms of, you know, computational frameworks that I use in my research, in terms of modeling, I use a subcategory of machine learning called reinforcement learning, which is a class of models that describe how people, or, you know, any computational agent learns from trial and error. So the whole idea is, you know, when I do something and it gives me a positive outcome, I'm going to want to do it again, okay, whether human or robot, right? And then if I do something and there's a negative outcome, then I'm going to do it less, right? So this is an algorithm that describes how humans learn and is also class of machine learning algorithms that can model human behavior or can train robots to learn really diverse and cool skills. So there's reinforcement learning, and there's also information theory, which is another subclass of statistics that describes how information is is communicated from like an input to an output, and how that information is processed and used. So there's a lot of different computational tools that are taken from traditional statistics or machine learning that are very useful in my research, even though on first glance, like those things seem very removed from like human behavior or psychology, but they're actually very intertwined.
That's really cool to hear, especially because I think one thing that drew me, I'm a cognitive science major, into this field, and kind of in adding a data science minor for me, it was just realizing how connected both things are, and I think that's really amazing, and I feel like not a lot of students really know that. Like, I think a lot of data science students, they know neural networks, reinforcement learning, they kind of know them as machine learning frameworks that robots do, but they don't necessarily know that a lot of them have roots in neuroscience and that field of study. So
exactly.
Yeah, that's really cool. And I also kind of wanted to ask, where do you think that kind of analogy stops? Like where, you can think of your brain as a machine, but, where do you think it kind of like drifts away, like where there's more nuance to it?
Yeah, that's a great question. And is one that's discussed a lot in the machine learning community, especially people who would like to draw insights from human behavior and apply them to improving machine learning models, right? I mean, everyone can agree that there's certain things that machine learning or AI can do way better than us. Like they have a lot more data. AI is more accurate a lot of the times than we can be because they have so much more information that they're trained on. But I think that something that people kind of dismiss a lot of the times is the fact that like there are a lot of simple things that machines still can't do as well as humans, even as well as babies. So for example, like babies, just like a few months old can learn something from just one presentation, one example of it. Whereas machines, they're often trained with many thousands, millions of examples of something just to really understand and recognize, like, for example, what an image of a dog is, right? But if you point to a dog and say to a baby, like, that's dog, and the baby says dog, like the baby very quickly understands the concept of a dog and can also apply that concept and generalize it to many different types of dogs. You don't need to point to all the different species of dogs for a baby to understand of like what exactly a dog is. So I think in that sense, in terms of like the learning process that we as humans have is still really, really unique compared to how machine learning models and AI learn and are trained.
Yeah, I always hear about I guess like when kids are young, they can, pick up things so quickly, like language, for example. That's, so interesting because it takes so much computing power for a computer to be able to do the same thing.
Yeah.
Do you think, what do you think like the slope of like, I guess people talk about like AGI. I don't really know how, I think people use that as like a marketing term a lot of the times, like these tech companies, but how close do you think the current systems are to, actually emulating human cognition right now?
Yeah, I mean, I feel like a lot of people are working on this type of thing. I personally don't work on improving AI directly. I joke to people that I'm more interested in natural intelligence rather than artificial intelligence. But I also just think it depends on your objective, right? Like some people want to create AI that is as good as and even better, like an evolved human. But others are more concerned about just developing AI in a way that is most compatible or most useful to us as humans, right? So you're optimizing for different things. Like one is like you want to create something that's like almost exactly the same, and in the other you're trying to create something complementary that can really work well with humans and have strengths that we don't have,
Mm-hmm.
right? So it kind of depends on who you're asking, but I do think that just the rapid advancement of AI capabilities and just the sheer power of what they can produce and learn and even reason about has exploded in just the last 5 years. So I think we're getting really, really close to, I essentially think we're at human-like intelligence, to be honest. But the way they learn things and the way they do things is still quite different than humans. And I don't know if that it really should be the goal, is to make them do things exactly like us. But in terms of fooling a human, I think we've passed the Turing test, which is like, can an AI fool you into thinking that it's human? It can.
It can. I remember there was like an old lady on the train. I was taking like the Amtrak once, and she was on call, and there was like a customer service agent on the other side of the phone. And it sounded like, to me, it sounded like AI. Like it sounded like the customer service. It was repeating, very kind of AI sort of like diction. But I think to her, she was really confused because she couldn't tell. And I think
Poor
that's
woman.
really hard. Yeah, for sure. But it is at the point where, it is fooling people. And I think that's really crazy. And then I also wanted to ask you more about computational modeling, coming back to that. So I think, a lot of things, a lot of processes like can be modeled, but, for you, based on your research, what kind of decisions do you think are the hardest to model right now?
Yeah, good question. I think to answer that, maybe I'll start with like, what's the purpose of computational modeling? Because why can't you just like describe what people do in words, right? Which is like most of the field of psychology. I think the purpose of computational modeling is that you make your assumptions explicit, right? So for example, like if I'm trying to explain like, why does someone choose A over B, right? You can just say, well, they like A more than they like B. In a computational model, you really formalize what exactly you're talking about. So I can say in my model that, they choose A over B because the value of A is higher than the value of B, right? Whether that's like subjective value or something like monetary value, you're clarifying exactly what you mean, that people choose things according to the value of different options, for example, right? And so modeling things computationally allows you to test assumptions of your model, like whether they're true or not, and compare them to actual data. And it also allows you to experiment with the model. So let's say like, what if I introduced like options C and D that have different values? Like, how should a person choose in that case, right? You can test those predictions explicitly. As for decisions that are hard to model, I think, not all human decisions are about choosing between A and B. So, and a lot of our decisions are very complex and have a lot of factors that go into it. For example, like our values and morals and, what we're taught to, like our upbringing, for example. And just today I was thinking about this question of meta preferences, which is how does someone want something? Or what does it mean to want something? Can we model that computationally? And that seems kind of hard because it's like a meta preference, right? So it's like, it's not as simple as saying like the value of A is more than the value of B, because it's saying like, I want A, but I want to want B. Right. So, a lot of these more complicated, higher order cognitive functions are sometimes quite complex to model.
Yeah. Is it, in research with these types of models, is it common to like use money as one of those, like choosing between like A amount of money and B amount of money? I hear that a lot. But other than money, what other decisions do you are typically modeled in research in this field?
Yeah, money has been a pretty classic test case because, I mean, money is a primary
Yeah,
incentive in society and in human behavior.
Yeah.
The other biggest incentive is like food or
Mhm.
social incentives,
Oh,
right? So people
mhm.
are primarily driven by like those three things: money, food,
Mhm.
and social drivers,
Mhm.
right? So people like, for example, in social drivers, people study this in game theory, which is like a subfield of economics of how you should best like interact with your opponent if you're playing like a game against them, for
Mhm.
example. And then in a lot of animal research, food incentives are really studied. For example, they try to see if offering 3 drops of juice will motivate an animal to do something more than 2 drops of juice, for another behavior.
Mhm.
So that's typical.
That's so cool. Do you like compare like animal behavior to human behavior like in your research a lot?
Yeah, good question. So
Mhm.
I myself don't do
Mhm.
like animal studies, but in the past I have collaborated with groups that study animal behavior, particularly rat behavior. Rats are quite
Mhm.
smart. And so there are certain cases where it's useful to compare animal and human behavior. For example, in these simple 2-choice tasks like choosing A or B for different outcomes. The advantage of studying animals is that you can look into their brains a lot more easily than you can look into the brains of humans
Mhm.
a lot of the times. But humans can do a lot more complex cognitive tasks, so there's definitely a trade-off there. But both are informative for understanding the brain.
Mhm. Yeah, all those poor rats.
Yeah, exactly.
But yeah, that's really interesting to think about like the different research methods we
Mhm.
use in this field. Because I feel like it's definitely a lot less talked about in like my cognitive science classes. I feel like the study of decision making, it's like kind of a rare sub niche, I would say. But I think that's really awesome. You mentioned that some of your current research interests were observing intellectual agency. So what is something that kind of pulled you there, and would you say any of it's like driven by your teaching or any interactions you've had with your students?
Yeah. So, well, first of all, I'll say I'm interested in a lot of different things, so I can never really
Yeah.
like focus my research on just one thing. But in terms of intellectual agency, yeah. So this was really also motivated by my interest in how AI is changing education and how students learn, and I think this is more of just like a very exploratory area of my research where I want to understand like you know what do students prefer to export to AI, and what do they still want to have intellectual agency over when they're really forced to think about it. Okay, of course when they're like stressed they might just export everything to AI, tell it to do my homework and stuff, but where's like the real value of learning for students? What that feeling of struggling through a problem, like let's say you're doing like a difficult mathematical proof, and then finally getting it and really having that moment of insight where you really feel like you understood it, is really motivating, I think, and really makes you feel like you know something, right? So it's like, in what context are students able to choose for themselves that they want to do something hard rather than exporting things to AI? So it's kind of like an open question for my students.
Is that something you're asking like in surveys with your students, or do you know any other ways that you would explore this more?
Yeah, I think primarily it's going to be, I haven't done any of this yet, but primarily it's going to be like kind of a qualitative type of survey where I'm really trying to understand. And I think my guess is actually that students haven't actually been properly taught or informed about the ways they could use AI to support them instead of like just entirely replace their thinking. And so the default is to just go and replace your own thinking, right? And so I do wonder if there's some way we can help teach people to use AI that's helpful for their learning, but that's not completely replacing like their intellectual agency of choosing what to learn and choosing to struggle through something for like a greater long-term reward.
Yeah, and is that definitely something you would be going into like in the potential like future class that you mentioned?
Yes, for sure. Yeah.
Yeah, that's so cool. And I guess like how would you say, I know like your classes, you teach a lot of different types of majors. Have you seen kind of a difference in how, like, say, a data science major uses AI to help them versus like a cog sci major or like a psych major?
That's a great question. I would love to study that. And
Mhm.
in my kind of just observations, I found that like data science majors or people who are a little bit more like programming savvy tend to use AI a lot more. Maybe because there's a lot of coding tools that are very helpful. And then students who study more just like pure behavioral neuroscience or like pure cognitive science without much like computational background, I feel have less experience overall with AI because it's just not the correct like use case for them, or some of them are even quite opposed to using AI for a lot of things. So
Yeah.
I do find that there's like a dichotomy among students.
I definitely see that as well. Like among my like CS data science, like even some cog sci friends would be a lot more open to using AI versus like my behavioral science friends. Like I know some friends in poli sci or like psych, sociology who are just like completely anti-AI because it makes sense for a lot of their assignments. It's honestly not all that helpful, and it's not really something that is going to be as pushed in the industry that they go into, because a lot of students, like a lot of students going into tech know that once they're in industry, they're going to be pushed to use it.
That's true. And but what's funny is like the people who are using AI the most are also the people who have the most risk of having their jobs replaced by AI.
Yeah.
I'm just thinking because like, for example, like my husband is a dentist, and him and his friends primarily use like AI tools to like come up with memes or like make funny images of each other, whereas like we're using AI here to like write our code, and it's like dentists can't really be replaced by AI, so it's more of just like a fun tool for them.
Yeah, no, that's crazy. I definitely see that the people whose jobs are at the most risk are using it the most. It's concerning. I think like a lot of data science education it's been changing just based on the tools people use in industry.
Yeah, for sure.
Every few years like a new tool comes in, and it's really hard for a curriculum to keep up with that. So I noticed your classes, like things like Cogs 9 and Cogs 109, they focus less on those tools and frameworks and more on the high level like concepts around data science and modeling. And in a field that's changing this fast, why do you think it's really important to have these high-level fundamentals down?
1,000%. Yeah, I think that tools come and go, like you said, and so many tools have come and gone even in my education, right? Like I first learned to program in Java, and people learned to program in C++, and now the primary languages are Python and R. AI is a tool we all need to learn now, right? And so, and I think for tools, like you can teach tools, but really like the way you get good at a tool is just by using it like a lot, like every day, right? Yeah. And so I think that beyond the tools that come and go, like the fundamentals, the theoretical knowledge and skills are really the things that stay. And also the things that distinguish people who really know what they're doing versus people who just know how to use tools well, right? So in my classes, I really emphasize, the importance of really knowing the foundational concepts well. And for example, like in COGS 109, like, we learn about linear regression, logistic regression, like the two most simple statistical / machine learning models that are a foundation for many other models that are more complicated, that just basically stack those types of models on top of each other. And so, in the simplest form of linear regression is like a line, right? Y equals mx plus b, like you learned this in high school. But, do we understand what m in the equation means? Do we understand what b means, right? Do we understand the behavior of y as we change x? Right? These are really fundamental intuitions that will never change, no matter what tools come and go. And beyond that, I really care a lot about students knowing what type of model to use in every situation, in every context, depending on what data set they're using. Because this is the type of stuff that, I mean, I guess you can ask AI, what should I do? But a lot of modeling choices still depend highly on the context of something, like domain knowledge that you might just have to know through experience. And sometimes AI models are not always accurate about those things, right?
Mm-hmm.
So knowing the fundamentals, those things will never change. So yeah, that's what I encourage.
Mm-hmm. Yeah, and I think that's so amazing because a lot of the times, like in things like interviews, beyond just being able to code out like a model, it's really more expected that you'd be able to, interpret it and interpret what each parameter in it is. So I think that's so important to, get those fundamentals down before you go into like anything else. And yeah, I think that's really amazing. And I guess more on going, like different career paths. So obviously a lot of data science majors want to go into industry, but I'm sure, there's a lot as well who are interested in going to academia, going into research, specifically in the social sciences. So I wanted to ask about how you would describe maybe like the transition from a technical undergrad to like a more behavioral sciences grad program, and also like vice versa. Like how is a transition from a social sciences undergrad to a more computational focused grad program?
Yeah, great question. So I think like the social sciences is a really rich domain to apply data science to, and vice versa, because traditionally social science has not been a super quantitative discipline, right? There's a lot of observational studies, qualitative studies, but with the wealth of data that is in a lot of social science domains. To give you an example, like social networks, right? Like previously it was hard to study social networks because, you'd have to go and like survey or capture interactions between people, right? In like a village or something, right? But now we have like these things, we have social media, right? And social media is like this online social network that you can study. You can study, for example, how people on Twitter, it's called X now, how people on X like interact with each other, how those interactions change people's behavior on what they share and that kind of stuff, right? So there's now this wealth of data that's online that we can study with tools from data science, right? With network analysis, graph theory, all these computational tools. Similarly in psychology, right? Like previously, people did these like 10-person studies where, they wanted to understand if, someone would intervene if someone else was being hurt, for example, right? But now psychological studies can be run online at a very large scale in a very quick way. So the data is becoming more and more accessible in these domains, and there needs to be a way to understand that massive amount of data and the patterns that are there, right? And then for data scientists, I would say, I always tell every data science student this, it's like data science wasn't a major that existed like 10 years ago, it certainly wasn't when I was in college. And back in the day, like you would just learn the subject you were interested in, like the topic you were interested in, like let's say like sociology or like anthropology, and then you would learn some like computational skills that you could apply to that field, right? And then you could maybe become a data scientist of some sort. But now you start off as a data scientist, which means you have all these skills, but one of the most important things in being a data scientist is that you need to have something to apply those skills to, right? So instead of just everyone wanting to work on AI, I really recommend people find a niche, a topic that they're really interested in intrinsically. So like if you're interested in space, maybe you can apply data science to understanding like, planets and asteroids or whatever. And if you're really interested in climate, maybe you can apply data science to understanding climate change. Okay? There's so many things that you could apply your skills to.
Yeah, for sure. And like, I think that's so important because if, domain knowledge is probably the one thing, something like AI won't be, like it might be able to write the code, but it won't have the breadth of the domain knowledge that you would gain in a particular field. So I think that's so important. And everyone kind of wants to gain experience, like data science majors, anybody who's interested in a particular niche, they want to gain knowledge, and a lot of that is done through research experience as an undergrad. So I'm sure you went straight into your PhD, so I assume you had undergrad research experience.
Mm-hmm.
So how would you suggest getting access to undergrad research, either reaching out to professors or once you're already in a lab, how would you recommend a student approaches undergrad research?
Yeah. I think undergraduate research is an amazing opportunity because, especially at UCSD, it's like a quarter system, right? So in 10 weeks, you can only learn so much. Even if the class has a project as your final product, it's still very short amount of time to produce something, right? So research allows you to hope, in some cases, work on something for more than just one quarter, right? For a long time with a faculty mentor. And if you're interested in research, I would first try to figure out or maybe narrow down a little bit what exactly you're interested in, right? What topics, right? Read a bunch of things and figure out what topics are most intriguing to you. Because that's the most important thing is to be motivated and want to do the research, right?
Mm-hmm.
And then next, I would say of course, here at UCSD, there's limited opportunities, right? Because professors are bandwidth limited, and I would love to take every student that approaches me, but I just can't, right? And so, if you reach out to a professor, you want to keep it succinct, but also with enough information that you would stand out to them as not just someone else sending a generic email about wanting to participate in research, right? So tell them a little bit about yourself, what you're interested in, why you're interested in their work, and ideally, I think to really stand out, show that you've really looked into their work, you've read maybe one or two of their papers, and that you actually have thoughts about their research, right? Maybe you have a question from the paper their paper that you read, or maybe you even have an idea of how an idea from their paper could be extended, just to show that you actually thought about what they work on. I think that would really stand out. And beyond just UCSD, there are a lot of summer opportunities at UCSD and also across the nation and other campuses that basically pay you to do research for 10 to 12 weeks as a summer research fellow, right? So those opportunities can also be really great experiences to really dive headfirst into research and really learn something in a short amount of time.
Mm-hmm. No, undergrad research is honestly so rewarding, and I think my first experience with basically any data science tools was through research, more so than classes. I feel like it was research that was what really got me hooked. So
Mm-hmm.
even if someone's planning on going into industry, I feel like undergrad research is such an amazing opportunity to learn, especially at UCSD when you have access to such a huge research university.
Exactly.
Mm-hmm. Yeah, and I guess as a closing question, I wanted to ask, it's you're almost done with your first full school year at UCSD. So far, what's been the most surprising thing as well as the most rewarding thing that you've experienced here?
That's a great question. The most surprising thing I think has just been how large it is here. I mean, I come from very small schools before, so just the massive amount of students that just walk across campus in every passing period. And even just in the intro class I teach, standing in front of 300 something students twice a week is astonishing to me. And every day that I'm up there teaching, I feel like it's such a privilege to be the person that 300 people are listening to at one point in time. And so I feel very fortunate that I get to play a part in you guys' education in this way.
Mm-hmm.
And then the most rewarding thing I think has been being really personally involved with students and in their educational journey. And so I love to connect with every single one of my students personally. And unfortunately, that is really hard when I teach so many students in one quarter. But I think like with my TAs and with the students that work with me on research projects, I do really feel like having that kind of one-to-one relationship with them has been so rewarding, and getting to write them letters of recommendation that have helped them get into like graduate programs, and just really seeing how they have so much potential and maybe they don't even see it themselves, but giving them that push to like pursue something that they're kind of thinking about but maybe don't have the confidence to go for, and then seeing them actually get it and achieve it is like the most rewarding thing. It's like the best part of my job.
Oh, that's so awesome to hear, and I'm so glad that you're liking it here at UCSD. I also like had the same reaction when I first came here. Like, it's such a big school. Like, the campus is big and there's just like so many people. But yeah, I just wanted to thank you for being here and for sharing, your experiences and advice to our audience. And yeah, thank you so much for listening.
Thank you.